Well, my name is Garrett Griffith, and for my senior project, I did a handheld scanner calibration fixture. So what you're looking at here is a photo of my entire project, and this part right here with the circuit board, you can also see it up front, is the actual frame of the scanner. We'll talk more about that here in a second, but we're going to work towards the end product, which is sitting on the table and on the screen here. So, a quick overview of what I'm going to discuss today. I'm going to first talk about Provel Inc., which is the company that I'm currently working for. I'm going to talk about the product that that company is currently developing, which they call their S1 scanner. I'm going to move into the problem statement, which my project was a subset of their much larger scanner development project. And I'll cover the design, testing, and results of my project, and then I'll wrap it up. Before I get going, I'd like to thank these three gentlemen here. On the left, David Firth, my boss, an industrial designer, 20 plus years of design experience. I learned a lot from him throughout this project. And then these two guys on the right are my coworkers, Matt Akers and Brendan Beardsley, Roger's son. So again, big thanks to them. Huge help, couldn't have done it without. So starting with Provel, David began work in the orthotics and prosthetics industry over 20 years ago. He worked for a company called Seattle Lightfoot. He designed prosthetic feet. And then he branched out and made his own company called Provel. They've been in business for 21 years. We see here on the left a digitizer, in the middle a carver, which is a CNC lathe, and on the right a thermoformer. So a patient would have their residual limb cast. It would then be digitized with the first machine. A foam duplicate of that cast would be made, a positive mold on the carver, and then that foam would be inserted into the thermoformer, and a hard plastic adapter would be made to perfectly fit the patient's leg with this third machine, the thermoformer. So that's how it was done. Right now, though, they're developing the Provel S1 scanner, which is going to replace that hard molding process and that digitizing process with a little gun-like scanner that you just walk around the patient and scan it into 3D. You then import it into the computer. You have a 3D model which you can manipulate and change as needed. And so this will hugely revolutionize the orthotics and prosthetics industry. This technology is out there right now. However, the current technology is much slower, and it requires a USB cable to be connected to a PC. Since a lot of the computing is done on a computer, it's not all done on the board of the scanner currently. So the one that they're developing over there at Provel is going to hopefully blow all those out of the water. It's still in the development process. We'll talk about that a little bit more later. So the way that it works is that it emits this strange pattern of light onto a surface. So here we see the pattern of vertical bars emitted onto a flat surface. You'll notice there's really no rhyme or reason to the number of black lines versus the number of white lines, the width of the black lines versus the width of the white lines. It looks random, but the computer knows exactly what it's looking at. It's very similar to a barcode. So when you first start with this reference image, it's called, and then from there on out, every time you pull the trigger on that scanner, it compares the shape that it's seeing to that reference image. So that's what my project was to create the fixture that would allow the scanner to take an image of a perfectly flat surface that it's perfectly square to, such that the computer knows from then on out exactly what it's looking at. So again, every single time you pull the trigger, it will reference the image that it took in my fixture. So I think this is a cool effect here. Moving on. On the left here, we see the plastic removed, half of the plastic removed from the scanner to expose some of the insides. What we're most concerned with is this piece right here. This is the aluminum frame of the scanner. It's also drawn here. Note that this drawing doesn't include the bends. There are also 3 precise bends throughout the scanner frame. So my project was to clamp onto that scanner frame and hold it squarely and get that reference image. So, sounds simple, but there were some stipulations. As I've already mentioned, it must be held parallel to the reference plane. So the camera of the scanner has a plane of it on that frame, and if those two planes aren't parallel, then it's not going to take an accurate image. So the distance between must be the same, top to bottom. The surface must be flat any imperfections or irregularities in the reference plane will be irregularities in every single image that that scanner takes. We needed it to be adjustable, so when you initially set it up, we were going to set the distance as well as throughout the life of the product. You never know how it'll evolve, if it needs to be changed, so it just needed to be adjustable throughout. Once it's clamped into the frame, you need to be able to get in there and adjust lights, as well as there are buttons and power connectors. So those are, you can maybe see in the front row here. Buttons and such are down here on the bottom left, and the adjustment screws for the lights can be found on the back here. So if my fixture would have covered those, it would have been essentially worthless. So again, power supply, portable for bench top use. So essentially we didn't want something that weighed 1,000 pounds and could never be moved, because throughout its life it may find a new home throughout the shop. If it didn't work repeatedly and consistently, again, it's no good. Every single scanner needs to go in there and be clamped, and they all need to take the same reference image. And easy to use. I mean, if we're going to be using this to mass produce these things, the last thing we want is to have to fight it every day. So, jumping right into design, this looks like I started off on the right track, but really I was all over the place in my initial designs. But if you'll notice, I gravitated towards a design that included a beam for the frame at the base, a section of angle to adapt that to the screen, and some type of vice mechanism to clamp the frame. This design here was not actually adopted, but it involved a hinge and a pin and a clamp mechanism to hold it. That's very close to the final design, but again, as you'll see here, this is the final design. Instead of a hinging thing that was kind of flimsy and hard to make, I instead went with 2 bolts and this part here I called the mast. It actually supported the whole vice assembly. Tightening these 2 knobs moved the other vice jaw into it, and then the 2 in unison clamped the frame of the scanner. You'll see here that when the hole through which the camera lens protrudes is resting on the bottom bolt, that centers the portion of the frame that is the reference plane. It centers it within the vice jaw so that you're not clamping on the bends of the scanner frame. And moving on, here's a few of my more interesting component files. Just kind of, again, a little overview of my final design. These are some of the more involved pieces. This piece on the top here, top right, is just a purchased part that I cut to length. So I didn't design Bosch beam, I just used one. All these other ones were made from stock. Here's a couple of assembly drawings, just showing the sub-assemblies that get you from here to the final product. And with the design in mind, it was time to hit the shop. So over a course of a few nights, I was able to bang that out in the shop. This is Provel, taken from a few different angles. So top left, this is kind of the big work area. Top right, this is the view of the back shop. So I made use of the chop saws, the drill press, and then the bottom left, I used the mill there. And then this is the big wall of stock that we have. So some piece of aluminum right in here somewhere is what I made my mast out of. And there it is. So I got it all done. You'll notice in this picture I'm using some larger knobs that actually interfere with each other as they rotate. So those were not used in the final design, as well as these washers are smaller outer diameter than the ones that I eventually went with. The bigger the washer, the more area that you can spread that clamping force over, and thus reduce the risk of indenting the reference plane. So the larger washers for that reason. Here's a couple more detailed photos. Here we see the knobs that are currently on there with the frame of the scanner actually clamped into it, and a detail of the jaws of the vice. You see that this front part of this dovetail cut is the actual reference plane that the scanner frame is butted up against, and that part right there is the distance to the screen, the actual datum plane. So to test it, I essentially needed to make sure that it worked easily and was square, as was the original requirements of the project. So here I'm using a machinist square and a feeler gauge, trying to determine just how square it is. I did that on all different angles, so I used the gauge down here, I used it up here, as well as over on the mast side to make sure that the mast was square. And what did I find? Well, unfortunately I was able to get a 1,000 feeler gauge into the, so that'd be this measurement right here, the vertical datum surface as it relates to the scanner frame distance-wise. So we get 90.057 degrees there, which was not actually within the original parameters. So I actually intend to go through and shim that and try and get that out of there. But as of right now, that angle is off, whereas everything else was as square as I could measure it to be. So that was promising, but again, we got to go back and rework that a bit. Another measurement that I did to make sure that the two planes were parallel to one another was I measured using a string. You can see here, I measured using a string to all the corners of the reference plane, and I did that at various different lengths to ensure that the two planes were square to each other. So those measurements are documented in this middle field here. And finally, I did a bunch of trial runs just to see how long it takes to swap the scanner frame out and make sure that it wasn't overly time-consuming or frustrating to use. One thing that was frustrating is that these knobs, like I said in the beginning, interfered, and at some points you're unscrewing them and they just fall off. So I maybe wind up rendering that also by counterboring the holes around the around those bolts there to expose a little more thread, make it less likely for the knob to want to fall off. And a video. Let's watch it in action here. If I recall, this does not work, of course. So get it open over here. Somebody close it in. Okay, so we start out just getting a good close-up view of the scanner frame. Getting a good look up at it, so you see the various adjustments. These are lights that are emitted to help you put the scanner at the proper distance. Within there also there's a digital camera. Alright, and now it's time to demonstrate its use. So I secure it with one hand, loosen the two clamping knobs there, make sure that it's free, and it should pop right out. You then grab another one, so let's say we just finished that one, it's all calibrated. The next one to be calibrated, you grab and you clamp it in place. Similarly, there I was touching off with the lens of the camera so that I knew I wasn't on the bends. It helps to orient it vertically that way. And you just check and make sure there's no play in there. It doesn't have to be tight, just tight enough to hold it flush up against that reference surface. And you're done. You're ready to calibrate another scanner frame. So chalk that up to a grand success. And so in conclusion, this project really taught me a lot about design. The design was hands down the most involved process. I went through a great many iterations of design and was shot down on every single one of them by my boss, which at the time was very frustrating, but in retrospect I learned that that attention to detail that he carries in his designs and really in every aspect of his life is what separates a mediocre designer from an excellent designer. So again, I got kind of a rare glimpse into the mind of somebody who does this professionally, and that to me was more valuable than anything else that I learned on this project. This image here shows the device as it sits in its home, which I had to take it away from to bring it down here today, but it's all nicely nestled in between those two windows, and it sits on that shelf there. But again, it was a great thing. It's exciting to watch a project evolve from nothing all the way into final tested product, and I'm glad I committed to it and followed through with it. And I thank you all very much for listening. Are there any questions?